In this video I'm going to make use of this file which contains a set of spectra from 5 different experiments. All these experiments are performed on a titanium foil, and the aim of these experiments is to investigate how the oxide that forms on the surface of the titanium metal evolves as a consequence of sputtering with an ion beam. The file as created contains data from each of the 5 experiments, and these appear in the first column of this data file, and they represent sputtering of the sample using 200 EV argon ions, 1000 and 2000 EV argon ions, and then 2 experiments that use helium ions of 1000 EV and 2000 EV. So we have 5 different experiments that should produce slightly different outcomes for the spectra, and what we would like to do is understand how these outcomes differ in terms of shapes that we can identify within the data. So the 5 shapes actually that we have found within the data represent 5 different phases of the oxide. In fact, it's 4 oxides and 1 metal, and these shapes are fitted to each of the spectra in a least square sense, and then the relative intensity of each of these shapes is measured by means of looking at the titanium 3p peak. The titanium 3p has a region defined so that the intensity above a background can be integrated for each of these component spectra when fitted to the data, and so we can measure the amount of each phase of this oxide by calculating the area for each one of these titanium 3p peaks, and then we can plot as a function of, in this case, the index of the measurement. The original measurements were measured against a sputter time, but each sputter time produced a different depth or a different response in the oxide, so the sputter time is not really as important in terms of looking at these 5 experiments as just simply saying these are different experiment cycles of XPS. I'll create the profile from these data using regions and the custom report on the report spec property page. Since each of these VAMAS blocks representing the component spectra already have the regions defined, I can select the VAMAS blocks, all of them, and then select in the custom report the regions button, which will copy through from the defined region names, which appears in the quantification item names list, the regions into the name formula column, which will represent the depth profile. So the names are how they will be described in the profile, and the formula is the name of the region from which the intensity will be gathered when the profile is calculated, and that will be performed when I press the area report. So all VAMAS blocks selected, press the area report, we get a report that is text-based, and each one of these columns represents intensity, and then it goes into the percentage concentration as calculated, and we can create a profile file by using the toolbar button create profile. And now we see the profile of the titanium 3p intensity as a function of the measurement index. There are some display options for displaying depth profiles, so I can just go for these default settings by selecting the toolbar buttons that are aimed at depth profiles. As a consequence, we get to see points as well as the traces for each one of these phases for these different experiments. And if we examine the traces, we can see how these 5 experiments progress. So we can see there's a metal, there's a phase 1, phase 2, phase 3, and titanium 4+, these are nominal assignments. That in the first example we see metal growing, and in the second one we see metal growing rather quickly, and in the third one not so quickly. In fact, these all represent argon sputtered titanium foil samples, and the first one is 200 EV, and so we don't see the rapid movement into the metal, whereas we do in the case of the 2000, and this is the 1000, and you can see that the 1000 produces the metal at a slower rate than the 2000. So these argon sputtered samples behave in a systematic way as a function of the energy of the argon ions, certainly in the case of the metal anyway. Now if we look at these final two experiments, these are sputtered using helium, and the helium ions are again 1000 eV and 2000 eV. However, we don't see a lot of difference between the two energies when we use helium ions to sputter the sample. In fact, we can only really see from the helium that the phase 1 immediately increases and then starts to decrease, and the phase 2 is the one that starts to develop in both cases as a consequence of exposure to the helium ions. And what's noteworthy is that throughout the entire measurement sputtering with helium, the metal signal remains constant. This has not changed over the course of the entire sputter cycles for helium. That's not the case for any of these argon sputtering where we can see the metal is progressing. So there's a different mechanism, but nevertheless the oxide is changed by whatever measurement we perform in terms of sputtering with an ion beam. Having data in this form gives me an opportunity to illustrate one of the display features of CASA. Each one of these traces is plotted with a colour and a symbol based on the order of selection at the moment. So if I were to deselect, for example, the metal and then overlay the selected VAMAS blocks using the same scale, then what happens is that the phase 1 now takes on the colour of the metal previously. So if you wanted to eliminate one of these traces from your display and then redisplay the traces that are of interest, the colours will change if this is the display mode that is used. Let me include the metal again. So now we can see the metal is the red trace with the triangles. If I go to the tile display parameters and the color property page, there is an option that says color by VAMAS block column. So instead of the order of selection, that these selections were made in the right hand side, now the color is determined by which column in the VAMAS file as displayed in the right hand side. So I'll enable that, and we see that the metal is red. If I deselect the metal, so the first one is phase 1, which is the color blue, that when I insert the new selection, it doesn't matter which order I selected these VAMAS blocks in, the colors will remain the same. So I've removed the metal signal and the red has gone, but all other traces are now using the same symbols and the same colors.